So we're going to talk about mean, median, and mode right now. So let's go ahead and get that started. Okay. So what we're going to talk about is measures of center. So the center of a data set is sometimes the best way to describe its location. So there's two that we use. We use the mean or the average or the median. So to calculate the mean weight of 50 people, I'm going to add 50 weights together and divide by 50. To find the median weight of 50 people, I order the data and find the number that splits the data in two parts. The median is generally a better way to describe the data because of outliers. But most people do talk about the mean, which is the average. So say I have a class and I have their final averages, and everybody did very well except for one person who say their average was a 25 for the whole entire class. When I look at that data, and if I want to turn my average for my class overall into my dean, I'm probably going to use my median, because that 25% final average that person got is going to bring down all my scores. So if I show my median, I'm going to have a better picture of how my grades were laid out. And so he can see that my median grade was something, so most people did well. So when you look at mean, there's some ways that we can figure it, but we're not going to do this by hand, but I just want to go ahead and talk about the theory behind it. A sample mean is represented by X bar. It's just an X with a bar over it. And to get that, what you do is you sum all of your data together and then you divide by N. That lowercase n is your sample size, and you'll often see that as we keep going further in this course. For the population mean, it's represented by the Greek letter mu. And to get the population mean, all you do is add up your values again and divide by your population size. There is no difference between your sample mean and your population mean. They're calculated the same way, so in the calculator, all it shows you is sample mean. So let's do an example together using the calculator. All right, so I'm going to bring up my calculator. I'm going to turn it on. So I'm going to enter my data. I'm going to go to stat and then hit enter. So I'm going to have, for my first value, I'm going to put 18. 18 is the next value. Even though I have two 18s, I want to include them because they're two different values. Then I have 16. Then I have 19, 24, 22, 37, 19, 21, 20, and 18. I don't even have to put these values in order because the calculator does it for me. So what I'm going to do now is I know I have 12 data values, and I'm going to just make sure that I put them all in. I'm double checking my work because I don't want to do anything incorrectly. So they're all in there. Okay. So then the next thing I do is I hit stat again and I scroll over to calc. And then if you see it says 1 var statistics, I'm going to hit enter and enter again. The first value I see is X bar, which is sample mean. That value is 20.75, so that's my mean. As I just said, my population mean and my sample mean are the same thing, so the average age of students in this Math 2200 class is 20.75 years, and that's how you figure it out. So let me keep going, and let's talk about the median because we can finish it up with the median. So the median is described as n plus 1 divided by 2, and that means we're looking at the location. So if n is an odd number, the median is the middle value of the order data from smallest to largest. If n is an even number, the median is equal to the two middle values, and then you divide them by 2 once you've added them together. So basically, if your n is an even number, the median will be the average of your two middle values, the mean of the two middle values. So here's an example. If I have 97 data values in a data set, then I'll do n plus 1 divided by 2. So 97 plus 1 divided by 2 gives me 49. The median is the 49th value in the ordered data. That doesn't mean the median is 49. It just means the 49th location in that data is that. If the total number of data values is 100, then n plus 1 divided by 2 equals 50.5. The median occurs midway between the 50th and the 100th value. The location of the median and the value of the median are not the same thing, but we don't even have to worry about that. So let me go back to my calculator, okay? This is the same data that I put in before. I'll show you. If I go to stat, hit enter, same data, it's already there. So if I hit stat again, go over to calc and hit enter, if I keep scrolling down, oops. Oh, I gotta hit enter again. If I keep scrolling down, look what it does for me. There's my median, it's 19. So remember we talked about this before. I have all my values again, because if I scroll up, look, there's my mean. Skip this stuff, keep going down. And right here is my sample size. We just talked about that, and that's a good way to check yourself if you have the right number of data values. Keep going down, and boom, there's median. It says MED. I didn't have to do it by hand. I didn't have to order the data. I didn't even have to worry about the number of data values in the data set. Don't do that. Just put it in the calculator, and it makes your life so much easier. Okay, and I have more instructions on how to put it in the calculator. All right, let's talk about an important concept. Mean versus median. So suppose that in a small town of 50 people, one person earns $500 million per year, and the other 49 earn $30,000. Which is a better measure of center, mean or median? Well, that one person who earns that much more money than the other 49 is an outlier, and they're going to skew the data. So it's so much more important to use the median than the mean. Remember I talked about my class data? That's the same premise behind this. And quickly, let's talk about the mode. It's another measure of center. We mainly use it for categorical data. So the mode is the value that occurs most frequently. There can be more than one mode in a data set, and there can also be no mode in a data set. So a data set with 2 modes is called bimodal. So let's look at this data set. Statistics exam scores for 20 students are as following: 50, 53, 59, 59, 63, 63, 72, 76, 78, 81, 83, 84, 90, and 93. Again, there are data values that occur more than once. So let's bring this up and let's talk about it. Okay, so let's look at it. Okay, so 59 occurs twice. 63 occurs twice. 72 occurs 5 times. And let's see, 84 occurs 3 times. Okay. So again, 59 occurred twice, 63 occurred 2 times, 72 occurred 5 times, and 84 occurred 3 times. I don't care about anything but the one that occurs the most. When the one that occurred the most is, I'm going to highlight it for us so we can see it, is this one. 72 occurred 5 times. So the mode is 72. I don't care about 59 or 63 or 84. I only want the one that occurred the most. So 72 is my example.